So, hello everyone. This is Zahid Bashir. I am a PhD scholar at Delhi College of Commerce and a faculty member in Department of Commerce, University of Gujarat. Last time we have discussed regarding the first generation unit root testing and its implication for panel ARDL. And I have discussed some basic studies regarding panel ARDL modeling. For example, this is the paper that I have discussed for understanding the procedure which is applied for panel ARDL. Uh, and before that, I have also discussed why we are going to use the panel ARDL. So let me recall the previous discussion. We were discussing the case where n is greater than 25 and t is also greater than 25 and cross-sectional dependence is not found. So when n is greater than 25, it means number of countries or number of firms are greater than 25 and time period is also greater than 25. In that case, the first thing that you need to see is whether there is a cross-sectional dependence in your panel or not. And if cross-sectional dependence is found, then you need to apply the second generation panel unit root testing that we have applied in a couple of our previous sessions. And if you found uh, the stationarity at level for the dependent variable as well as for independent variable, then you need to apply the common correlation effect. And in the same way, if you found stationarity at first difference for dependent variable and mixed stationarity for your independent variables, then you need to apply the dynamic common correlation effect. That was the route that we have applied for our previous sessions. In the last session, we have discussed when we do not found cross-sectional dependence in our t greater than 25 and n greater than 25, then we need to apply the first generation panel unit root test like IPS and LLC. And if we found uh, stationarity at level for DV and IVs, then we need to apply pooled OLS fixed effect random effect. But if we found stationarity at first difference for dependent variable and mixed at independent variables, then we need to apply the panel ARDL. So as we have tested stationarity and we have found mixed stationarity in independent variables, therefore we have started discussion on panel ARDL. So we need to understand what kind of things we need to consider for applying the panel ARDL. I have outlined some of the things here, like there are 39 countries and there is uh, uh, approximately 28 years data. So they are fulfilling the first condition of t greater than 25 and n greater than 25. The second thing is that they have applied Granger non-causality test, Haussmann test, and panel ARDL. In case of panel ARDL, we need to consider PMG, MG, and DFE. These are the estimators in panel ARDL. Like we have discussed the static panel with fixed effect, random effect, and pooled OLS. In the same way, panel ARDL focus on PMG, MG, and DFE. And the criteria for deciding whether we are going to consider PMG, MG, or DFE is Haussmann test here. So we will apply the Haussmann test to decide whether DFE is more valid here, PMG is valid here, or MG is valid here. The best thing about panel ARDL that it will display you short run as well as long run estimates of your regression result. When you discuss only the pooled effect, fixed effect, or random effect, it will display only long run estimates. it will not show you the short run estimate. But in case of panel ARDL, you will see the short run as well as the long run estimate. That is the difference between static panel and panel ARDL. All right. So what we have discussed in our last discussion, we have finalized an analysis procedure that we will discuss today. These are the countries. The first thing that we need to test is the cross-sectional dependence that we have already checked that it is not found. Then we need to apply the unit root test. We have applied this procedure and found mixed stationarity in our procedure. Then we need to apply the co-integration test that I will let you know in the next session. And then we need to apply the panel ARDL, that is PMG, MG, and DFE, that I will let you know today. So let us start the discussion of panel ARDL. First of all, you need to understand its econometric procedure, how the model is developed econometrically. This is basically the generalized ARDL model based on the panel. If you see this model where YIT is the dependent variable, like this one, and XIT is basically considered your explanatory variable or independent variable. Here you can see XIT. These are basically your explanatory variable. And this is another sign of lag that is considered the coefficients for lag dependent variable. You need to understand that you need to put here the optimal lag selection also. So I need to define here another thing, that is optimal lag selection. This is another thing that you need to find here. So first of all, in order to correctly apply the panel ARDL procedure, this is the correct procedure. First of all, CD test, then unit root test, then co-integration test, then optimal lag selection, and then you would be able to apply the panel ARDL procedure. So in this way, uh, you need to you need to understand the model, how this model is developed, and you need to apply this model. So if you see here with this sign, this is the change sign. Change sign is used when you are going to apply a short run uh, estimate procedure. While without this sign, the procedure is applied as a long run. Like this is also a short run procedure. Uh, yes, this one is also a short run procedure. So you need to understand that panel ARDL applies the short run as well as long run procedure. Now, you need to understand what is the difference between PMG, MG, and DFE. These are similar to fixed effect, random effect, and pooled OLS, but you need to understand the basic difference between these three commands. So, what is pooled MG or PMG? PMG is similar to pooled OLS. The salient feature of PMG is that it allows the short run coefficient, including the intercept and speed of adjustment and the error variance, to be heterogeneous between countries, because we are using the country's data. So it basically allows the short run coefficient, like I have already done with you, that in case of panel ARDL, you are going to estimate the short run coefficient as well as long run coefficient. So in case of PMG, you are going to estimate the short run coefficient, including the intercept, the speed of adjustment, and the error variance, to be heterogeneous between countries. while the long run coefficient is homogeneous across countries. So in short run, they have heterogeneous results for countries, while in case of long run, they have homogeneous results for countries. So uh, there are several requirements for validity, consistency, and efficiency of this methodology. The first thing that you need to understand here is the existence of long run relationship between the variable of interest requires the coefficient of error term to be negative. So you need to understand that your coefficient of error term should be negative. If you consider, if you want that there should be an existence of long-term relationship between the variable of interest. So this is the first requirement that you need to understand here, that the error correction term should be negative if you want to validate the long run relationship. An important assumption for the consistency of ARDL model is that the residual resulting from error correction model are serially uncorrelated. There should be no serial correlation in this model. So if there is a serial correlation in the model, you cannot validate your model. So remember this thing, that there should be no serial correlation in your model. And the explanatory variable can be treated as exogenous. So there should be no endogeneity issue in your model too. So there are some certain assumptions that we need to meet. The relative size of T and N is crucial since both are large. So we have confirmed this condition too, that N should be greater than 25 and T is also greater than 25. So it allows the researcher to use dynamic panel technique, which helps avoid bias in the mean estimator. So these are some of the considerations that we need to follow for applying PMG. Now, what are some of the consideration of mean group? The mean group estimates separate regression for each country. This is the first feature of this analysis. It separate the regression estimate for each country for long run as well as for short run. And the coefficient are calculated unweighted means of estimate coefficient for each country. Thus, it allows all coefficient to be heterogeneous. So in case of PMG, we were discussing that the short run coefficient should be heterogeneous for all countries, while the long run coefficient to be homogeneous for our countries. While in case of mean group, all the coefficient, whether they are short term or long term, they are considered heterogeneous. So that is the difference between both procedure. In case of PMG, the short run estimates would be considered heterogeneous, while long term estimate would be considered homogeneous. While in case of mean group, the all the estimates, whether they are short run or long run, they are considered heterogeneous. So this method needs have sufficiently large time and current and cross country covering 20 to 30 years. The same is the requirement. The dynamic fixed effect. The dynamic fixed effect estimator restrict the coefficient of the co-integrated vector to be equal across all panel. It also limit the speed of adjustment coefficient and the short run coefficient to be identical for all countries. However, it allows for country specific intercept. The basic difference between other and this procedure is basically this is fixed effect. Whenever you read this term fixed effect, it means there might be some cross-sectional effect in your model. So they have identified a country specific fixed effect here. So how to select the model, which model to be used, whether we are going to use the pooled mean group, the mean group, or dynamic fixed effect. So to select the best model among the PMG, MG, and DFE estimator, the Hausman test need to be employed. So this is the test which we are going to use to decide between PMG, MG, and DFE. So what is the null hypothesis? Null hypothesis is no significance difference between PMG and MG. The first decision that we need to take using the Hausman test is between PMG and MG. It means, first of all, we need to decide between PMG and MG. We will run the procedure of PMG and we will save the estimates. Then we will run the procedure of MG and we will save estimates. And then we will run the Hausman test. If Hausman test value gives you a p value less than 5%, it means you are going to apply the PMG. But if this value is greater than 5%, then you need to decide between the PMG and DFE. That is the next procedure. So we will apply the commands in the same way. Then there is a Granger causality test. I will let you know how this is applied. So these are basically the estimates that they have run. They have applied the descriptive statistics. We already know the procedure. They have applied the correlation coefficient. Then they have applied the unit root test. As I have told you that we are going to apply the LLC and IPS stationarity. That is more than enough for our estimates. And if you see, their estimates are stationary. Their estimates are stationary at level as well as at first difference. And you can see here, there are some mixed results also. So that is why they have decided to use panel ARDL. Then they apply the panel co-integration test using Pedroni and cow test and Westerland. This test is used in order to confirm whether there is a long-term relationship existing in your model or not. So we will see how they are applied. Then they have applied the panel ARDL using PMG, MG, and DFE. So they have find out some values here. Like you can see, this is PMG, this is MG, and this is DFE. So they have their long-term relationship LR and their short-term relationship SR. So if you can see here, in case of PMG, there are significant coefficients here, positive impact and significant impact, if you can see here. While in case of short run, you have found there is a negative error correction term. If you remember, I have told you that your error correction term should be negative. This is the line that I have referred. In case of PMG, you should have a coefficient on the error correction term to be negative. So this one basically validates your results here. Like you can see, error correction term. It is automatically calculated when we basically run the procedure. So if you see here, the error correction term is negative and it is also significant. So it's validate the pooled mean groups. But if it turned out to be positive, it means your estimates for pooled mean group is not efficient. Now, these are short-term estimates. If you see here, TFR for long run and FEDU is long run. These are long run estimates. These are positive and significant. But if you see the short run estimate, they are not significant. So here we can say that in case of long run estimates, in case of pooled mean group, the long run estimates of TFR and FDU, they are significant, but in short run, this is not significant. If we see the mean group estimate, you will notice that the ECT is not here because it is not calculated here. It may be positive in case of mean group. So you don't need to be worried. You need to only verify that it should be negative in case of pooled mean group. So in case of long run effect, both of the coefficient are not significant. And in case of short run, they are also not significant. But if we see the dynamic fixed effect, the TFR is negative but not significant, but the FEDU is significant and positive. And if you see the error correction term, this is also significant. And if you see the short run estimate for this command, it is significant also, but not with FEDU. So we need to see the Hausman test. If you see the Hausman test between PMG and MG, the value is less than 0.05. So it means you will decide, you will confirm the MG analysis, which means mean group. And if you run the procedure between PMG and DFG, you will see less than 5%. It means your DFE will be used. And if you decide between MG and DFE, DFE is final because in that case, the value is less than 5%. Sorry, greater than 5%. So you are going to use the DFE. So DFE here is the final model because its value is highly significant. So here it is confirmed that they are going to use the DFE model. So I will let you know the procedure how we can apply this, and this is the non-causality test. I will let you know how this is estimated. So let's start for our discussion today. What we are going to use today. I was using the high income data and I was using the panel unit root test. As I have told you that it is showing a mixed analysis because I have do not run the whole procedure, but if I run the whole procedure, it will give me a mixed analysis. So I have on the basis of my given results, I am going to use the panel ARDL. So let me open the Stata file so that I will let you know how to run the procedure more efficiently. So this is my Stata file. Now I am going to use the high income.dta file that I have shared with you in the previous session. So first of all, always remember that you need to run the procedure of declaring your data set to be panel xt set IDs and years. As we have run this command, now I will let you know the procedure and I will also share the file with you. So this is panel data, this is first generation, this is panel ARDL, and These are some of the files. I will show you the coding. This is the coding actually that I have applied. So this is the panel XP Westerland test. If we are going to use the test, we can apply, and this is Pepperoni test. Because both of these tests are applied when we are going to use the co-integration test. So what is the procedure? DV, IVs, constant tracks, lag 1, lead 1, bootstrap, and so on. So first of all, I need to confirm whether this test is installed in our command or not, because if you remember the procedure, I have told you that in order to correctly apply the panel ARDL, you need to find out the procedure. So the procedure is basically CD test, unit root test, and then co-integration test. So here cow, Pedroni, and Westerland test. So let's start from here. Rather than applying directly the panel ARDL, let's confirm whether there is co-integration in our model or not. So in that case, what we need to do, we need to apply this one, XT West for Westerland test of co-integration. So today we are going to confirm co-integration of panel ARDL. So XT West. So let me install this because this is the command that I am going to use for the first time. So SSC install XT West. So it will install this command. So let us install. So installation is complete. Now what I need to do, I need to copy this command from here, and I need to change the set of variables in my command. So before comma, I need to change the set of variables. Like I need to put my DV, then my IVs one by one here, like this. After exchange date, RGR. Now, the remaining procedure or the remaining part will be same. Constant trend, lag one, lead one, IR window, bootstrap one, and so on. The remaining procedure would be same, and press no more than 6 covariate can be specified. All right. We can specify only 6 covariates. So we can put here 1, 2, 3, 4, 5, 6. All right. Now we can run it. It have estimated with lag 1, lead 1, and constant and a trend at least 28 observation are required. Following series do not contain sufficient observation. So they require us this. All right, let run the procedure without these things. So what will happen if we run this command? The option lag has to be provided. All right, let's consider lags only. Now it is calculating. All right. So we should consider this part only. Now let's suppose I would I would consider the other variable too here, like this. No, only 6 variable you can specify. So you can see here the p-value. It is greater than 5%. It means your null hypothesis is not rejected. Your null hypothesis is that there is no co-integration, and it is not rejected because p-value is not less than 5%. If your p-value is less than 5%, then we can say that there is a co-integration. So here there is no co-integration in our results. So in the same way, you can also apply the Padroni test. So let's install first the Padroni. SSC install XT Padroni. Yes, installation is complete. Now we need to run this command XT Padroni. So we need to replace these variables with our existing set of variables, and let us check whether it allows all the variables all at once or not. The number of regression cannot exceed 7. So it has basically run the procedure, but with blank result. So we can check the 1, 2, 3, 4, 5, 6, 7. We need to remove the other ones in order to have the results. So there are some restrictions from these results that they can run the procedure with a certain number of variables. So this is channel co-integration test. And if you see here, the t-value is greater than 1.96. So we can have that your null hypothesis is rejected and there is co-integration in our results. So you need to see the t-value. If this value is greater than 1.96, it means that there is co-integration in your results. So you can confirm the co-integration using Padroni co-integration test. I will let you know how to report these results, but let us stick with this procedure. So after confirming the co-integration, you need to run the panel ARDL using this command. So first you need to understand this command, that this is your dependent variable and these are your independent variables basically. And then you run the long run estimate with lag dependent variable and your independent variables. And then this is the error correction, replace empty. So let's run this command here. What we need to do, we need to put our dependent variables first here, like FDI. Then we need to put our independent variable with difference term one by one. Because in case of short run estimate, we need to consider the first difference. So D dot my first independent variable, then D dot my second independent variable, then D dot my third independent variable, then D dot my fourth independent variable, then D dot my fifth independent variable, then D dot my sixth independent variable, then D dot my seventh independent variable, then D dot my eighth independent variable, then D dot my ninth independent variable, then E dot my 10th independent variable. Now, this first difference will basically estimate the short run estimates of your model. While for long run, you write here LR and you take the lag of your dependent variable first. My dependent variable here is FDI. So I take the lag. L dot FDI is basically the lag. So you need to put here L dot for taking the lag of your dependent variable, and then you need to put your independent variable without difference, because in case of LR or long run effect, you need to put your independent variable without first difference. So first difference is basically placed when you need to run the short run estimate, and without first difference, we take the long run effect. And then we need to write here EC, error correction term, and replace MG for mean group estimate. So you need to run this estimate. It says that XT-PMG unrecognized. It means we need to install it. SSC install XT-PMG. So it will install it and we will run the procedure. Installation complete. Now you can run the command again. And always remember that you need to make this command as we have run it previously. All right. What this says, met size is too small. Currently, met size is 400, so we need to set the met size. For example, set met size 5,000. Let's go. Because currently met size is 400. That's why it is not running the command. Now I can run the command. Same command you need to place here again, like this, and you need to erase the sign of greater than. Now the command is going to be run and you will see the results. It will take some time. If you see here, before the cap, it is running the command because this is a very heavy command. You are going towards the panel ARDL, so you need to wait for the results. So yes, now the command is run here. If you see the results, these are the long run estimates. If you can see here, these are the long run estimates, and this is your dependent variable. This is your independent variables. So you can see the long run estimates. None of the long run estimate is significant, but if you see the first difference, first of all, you need to see the ECT in short run estimate. It should be negative, and it is negative too. And if you see your independent variable at first difference, they are weakly significant because this value is less than 1.96. It is not significant. It is weakly significant, weakly significant, weakly significant, not